Good morning. Our topic for today is adding and subtracting angles. So we'll be looking at things like where is theta plus 180, where is theta plus 90. Before we do that, let's quickly think about what we would do on a number line. Same thing applies when we're dealing with angles. So theta plus 180, remember when we're measuring our angles, we start here, so there's theta, and I need to add 180 degrees to that. One thing that makes it easier to see 180 degrees is mark a little line like that, and we just keep turning, keep turning, keep turning, and there's theta in black plus 180 in red, and theta plus 180 would be right here. Theta plus 90 degrees, same idea. We've already turned this much, and now we need to keep going another 90 degrees. So it might be helpful to mark 90 degrees. So here, there is my 90-degree angle. So the red is another 90-degree turn, and theta plus 90 would be right here. And again, the original theta, and then the red is the additional 90-degree turn. All right, for these examples, we're given information about one turn theta and asked for a trig ratio for another. For the first one, the turn is theta plus 80, 180, so I need to start at theta and then turn another 180 degrees, which would get me to there. The coordinates for that point, I think you can see that for the original turn, the x-coordinate was the smaller number, and it's still going to be the smaller number here. So this will be negative 0.342 for the x-coordinate. The y-coordinate was up here at 0.94. On this one, the y-coordinate is down here at negative 0.94. To think about. One option is, I don't know what theta is, but imagine something close. So theta is approximately maybe 350 degrees. So negative theta, I'm thinking negative 350 degrees. So start here and go backwards 350 degrees, and that would get me right there. Go backwards 90 degrees, which would get us right here. With a 90-degree turn, the x and y coordinate are going to flip-flop. So what started out as a smallish x-coordinate turns into a smallish y-coordinate for the new turn. Right, so that was an x, now it's a y. Obviously, this has a positive y-coordinate. What was a biggish y-coordinate now turns into a biggish x-coordinate. The angle is theta plus 90 degrees. One option is theta plus 90 degrees is the same thing as 90 degrees plus theta. So we could start here, move 90 degrees, and then add this little piece theta, and that would be one way to locate theta plus 90 degrees. In this question, I'm given some information about theta and asked a bunch of other stuff. I'm going to first mark that information down. I'm going to think of the radius as being 7, so this much I'll think as 7, and then the x-coordinate is negative 5. I'm going to estimate that fairly carefully, so I think it's going to be about here. It helps if you draw this to scale, and so theta would be roughly there. I noticed that some other angles are involved, negative theta and theta plus 90, so I'm going to mark where those go. I'm now going to worry about the coordinates for the point and the angle we're at requested in part B. Notice for the point for theta and negative theta, the x-coordinate is the same, the y-coordinate is opposite of each other. The point for theta and theta plus 90, when you have a 90-degree rotation, the x and y coordinates are going to flip-flop. So I'll now show the work for the rest of the problem.